Hello and welcome to the stream. So hopefully everything is fine. My green screen has been a little bit uncooperative today, but I think it looks okay-ish, I guess. We'll see. So, continuing today with the refactoring, the massive, big, crazy refactoring that I started last weekend actually. But it has been going pretty well, to be honest. So far we have replaced the solve naked groups, solve hidden groups. And let me just switch around the restream. Okay, cool. So now the time is to replace the solve fish, which is kind of different because the previous ones we're working on top of a set or block of squares. Now with swordfish, I mean, sorry, not swordfish, that's a specific fish, but with all the fish rules, you work with a set of blocks, which makes things different. Okay. So let's just quickly jump back into the that's right. So just a reminder what the hell I'm talking about. So actually it might be easier to show it on my Sudoku Solver. Oopsie daisy. This one. Right. So let's imagine that you have a situation, of course not like that, what I actually want is this, right. So let's just work with the fours for now. Okay, so we have 3 fours here. Let's make this one like this. And let's make the, for example, this row the third one. Okay. Yeah. So I'm realizing this is a little bit hard to see, but if you look in this row, the 4 can only be in this column, and in this column. Then in this row, the columns overlap. So in this row, the 4 can only be in this column and this column. And then in this row, you have the same situation. So what this tells you that in these 3 columns, the 4 can only be in these 3 rows. So you can then go in and remove the 4 from all the other columns. And I just removed the 1 from the wrong one. Right. This column, so these 2 can go away. This one can go away, this one can go away, this one can go away, this one cannot, and this one can. And also for this one, right? But of course, to find this is a little bit tricky because you need to be looking at basically finding sets of rows or columns, and then you check the orthogonal direction. So if you are checking the rows, then you need to basically look what are the positions. Sorry, can I find a set of rows that basically have the positions of a specific number only in that many positions? So it's kind of a union of positions of numbers across rows or columns. And then you can go to the opposite direction and clean it from there. So that's kind of what these rules are, and they can basically be any size. As usual with Sudoku, you end up in situations where some of them become symmetrical, so you will not necessarily find a lot of the big ones because they usually kind of split up into, you know, 2 complementary stuff. But you can actually find pretty big fishes, and there are pretty funny names for those even. Where do I actually have that? I have it in the solve stats, don't I? Over here, right? So the size 2 is called an X-wing, size 3 is called a swordfish, size 4 is a jellyfish, size 5 is a squirmback whale, 6 is just a whale, and 7 is a leviathan. I think there was some name for size 8. Size 9 obviously doesn't make sense because then, you know, you have the numbers everywhere. And maybe even size 8 doesn't really make sense because then you are missing out on one column or a row. And does it actually work? Maybe it works, but it definitely overlaps with other stuff, so you probably will not run it into that. So yesterday I was kind of thinking, what do we do with the block checkers? Because so far, block checker in my Sudoku solver is very explicitly just a block of like the maximum number of squares you can put into a block, right? So in this case, it's very explicitly size of 9 if it's a 9x9 Sudoku, right? But for the other rules, and specifically the reason why I'm doing this entire refactoring is to actually introduce killer Sudokus. Well, for those, the blocks can be any size. They cannot be bigger than the size of Sudoku because for the killer blocks, the basic rule that, you know, you cannot repeat the number in the block still applies. But then of course there is this small killer block thing, which is even more complicated because that one actually can repeat numbers. So I was kind of thinking about how to represent those. One observation yesterday at the end of the stream was, well, if we have basically like two types of blocks, right? Like we can have a unique block and a non-unique block. For the non-unique block, the numbers can repeat, it's not a problem, right? For the unique blocks, the numbers straight up cannot repeat. So what we can do is just have these two classes to represent the unique and non-unique, and then just have like smaller block sizes as a special case of those. Not necessarily even introducing more data structures, but just, you know, having a simple check like is, you know, like a Boolean method that says, oh, this is actually a special block that has all the numbers. Because this is important for some of the solving techniques, because some of the solving techniques do rely on the fact that all the numbers have to be present in the block. Some of them don't. So for those it's fine, you can even run them on the smaller blocks, but there are definitely techniques that require you to have all the numbers in the block, otherwise they just don't work, because that's, you know, that's how they kind of force specific numbers. So yep, we do need two classes, unique block and non-unique block. Let's call it not non-unique block, let's call it something more reasonable. Let's call it generic block. Okay. Okay, so we kind of know what the unique block needs to have inside of it, right? Because we already have the block checker. So we need the vector of bit sets, because we changed square into a bit set. And then just like, you know, a bunch of methods that work with that. But before that, actually, let's just add libraries for these. So this will be actually, let's just put it into the core, because again, this will be reused everywhere. So unique block and generic block. Okay. Do I... Ah. Yes. Right, I will definitely need a vector. I will need the bit set, because that's the data structure I'm using. And yes, I will need to sort out the paths. I guess this will be just bit set as it is. Yes, okay, so this is the unique block. And it has to have vector of the bit sets, which is just the elements, right? Because now we want to actually represent different sized ones, I definitely need to remember what's like the maximum number. And I need to have the special method which is like is complete block, which will just return if the max is the same as the size of the vector, because this is a unique block, so if it has enough elements that it's pointing to, then I know that it's complete. Right. So over in the algorithms, we had the solvefish, right? So this will take pointers to unique blocks now. And I need to put in the include. Right. So okay, let's have a look at the implementation I had before then. Right, so we were basically unioning number positions. So again, if I go here, like look at the positions of a number in the row, I mean, across the rows I'm looking at, or across the columns I'm looking at. And if the total number of positions for that specific number is the same as the size of the set I'm looking at, I know I have a fish row. The one tricky thing over here is okay, is I need to skip over or I should be skipping over numbers that are set, I think, because otherwise yes, okay, so there were there was actually a problem that I run into, right? Because it's not just a simple addition. That's the issue. If I go over here, right? So this works as long as there are at least 2 positions for a specific number in each of the rows, because they need to somehow overlap when you're putting them together, right? If you only have 1 position, then you are kind of looking at the situation where this is basically like a smaller fish that has like 1 extra number just like appended to it. That's like completely unrelated. It doesn't necessarily break this logic, I don't think. But it's definitely wasteful to look at situations where you only have 1 position for a number in a row or a column. Because then you run into like weird situations like, okay, I can let's just erase this. So you can have situations basically like if I do this, right? These 3 ones, if I look at these 3 rows, would be detected as a fish, right? Because over 3 rows I have 3 instances of the number. But that's very obviously wrong. I mean, it wouldn't break anything because the like consequence of finding a fish is that you clear the columns of the number. And I mean, inherently, since we have a naked single, then you know, like the 1 cannot be in that column anyway. So it doesn't break the puzzle. But again, it's kind of like why would you do that work? It doesn't add anything to the puzzle. So yes, we need to make sure that the size is definitely at least 2. And then the actual logic was for across all the columns, which is the get call blocks that just returns the columns. We go over number positions. Oh, this is written in such a awkward way. Okay. Yeah, but basically, you know, figure out what the positions are, and then in those rows, just remove the number. The same idea here, but it goes the other way around, so this goes from the rows to the columns. So, right. So we will still need this kind of overarching logic, but now this thing basically gets called on. Okay, so we also definitely over here need another vector. This will be just called orthogonal. because so these are the blocks we are searching across. So this would be like the columns, for example. And in that case, you need to pass in the set of blocks you actually want to clear it out of, which for the first one is columns, the second one should be rows, right? And right, then it's not just the size, it's actually also the number. Because the fish rules are always for a specific number. You're looking at the positions of a specific number and then clearing that number out of the orthogonal blocks. Right, so let's see. Okay. So I think the logic is kind of the same as before. We start with this. So we are still kind of assuming a square puzzle here. I don't really think we can get away from that. I mean, this would actually work for non-square puzzles, but then you kind of need to be only looking in one direction, and that direction has to have all the numbers. Yeah, like I'm kind of imagining a puzzle that's kind of, you know, something like this. You could have like 6 by 3 blocks or something like that, and then you say, like, you know, numbers 1 to 6 go into each row, and each like 2 columns or something. But then, you know, if I have like 2 instances of number 1 in the bottom and top row, then clearly I can just like remove the instances out of the second row in those columns. It's not as strong, but it would actually work. But this is fine again. So like in the initiating direction kind of needs to have all the numbers. So this is the blocks.size, so that's fine. So then we need to, okay, then we need this loop that we have over here. Oopsie daisy. Come on. Yes, this loop we kind of need to reuse. Where did my function go? Here. Okay. But this goes away, right? So each of the iterations gives us a selection of in this dimension, basically selection of these blocks, right? So now I want to go over those blocks. Basically it's the same idea as over here. Go over this set and figure out the positions. But I want to do it slightly smarter. So what I actually want to do is for number positions in a block to actually return a bit set again. Because previously this was actually returning an unordered set, which is really not good. It's just unnecessary complexity that really doesn't have to be here, right? So this is returning unordered set, and we just do inserts. But you can do exactly the same thing with just a bit set, except like there's no dynamic allocation happening because like unordered set is basically node based. If bit set is just one number, so it's way more efficient. It probably won't matter that much. Like I wouldn't. Maybe, yeah. Like the unordered set was popping up a bit in the profiles before I started this refactoring. So I think like overall, like all these changes I'm making are definitely making things better. By how much? That's an interesting question. I don't have a good gauge on that yet. But yeah, we are. I mean, this is all heading in the correct direction for sure, which is kind of the only thing I care about. Okay, so here we want to do the going over the numbers. Do I have that somewhere? I don't have it over here. Okay, never mind. So I can do it very simply. So let's call this position. So we start with a 0, right? And then while position set to iter dot next, was it next? Or was it next bit? Okay, let's quickly check. This thing is next set, next bit, right? Man, my memory, like things I did yesterday, I already don't remember. What the heck? I'm really getting older. Like this is no joke. Right. So next bit from iter, it takes a bit set and the current, right? So from iter with position. So while this is not 0, that's what we want to loop. So again, this will just iterate over all the bits set in the bit set, and since the bit set represents a group of rows or columns, basically group of blocks, then what all we basically do here is just blocks position -1 dot okay, and I need a new bit set. Set equals slightly complicated. So this one will be empty with num_lm. Is that it? Yes. Okay. So we get an empty bit set, and then here I actually want to remember this for a bit. So number positions of number. So this I will need to keep, but it will now return the bit set. And then if x dot count set is bigger or equal than 2, then I actually want to add it into the set. So set join with x. So this is basically this thing. Okay. So once this is over, we have a set that has the positions of this number we care about across these blocks. So and this will be ordinal numbers again, so it will be 1 based, starting at 1, because that's how we count bits in our bit sets. So our bits go from 1 to 64. So now what we want to do with this is basically check if set count set is the same as size. So again, this is the check if the number of positions of this number across these blocks is the same as the number of the blocks, because that's the size of the set we are iterating over, and you know, this is the thing that guards the positions. So if this is the case, then we actually want to remove something. So this will be where the like pruning code will be. And I'm a bit tempted to just invert this, because I'm not super fond of like deeply nested ifs, and there will definitely be something here. So I'm kind of tempting inverting this. The only reason why I'm kind of considering not to do that is because we have this end of loop, you know, iteration. So if I invert this if, then I need to have this code basically twice, which is, it tends to be a little bit error prone. So I'm, yeah, considering, but yeah, we'll see. And the actual pruning is basically this thing over here. Okay. Okay. Yeah, I think I need to write the number positions. But here I actually have the set. Right, so I think here I had to kind of double count this, because I think I'm kind of losing the yes, so I'm here I kind of lost the set, because I'm calculating the set over here and it's not getting stored. The only thing that's getting stored is basically the blocks involved in the set. So here I actually need to recount this. So this I can skip because I already have that, and I really just need to do this. So okay, so this is not too bad. This is not too bad. I can do this. Okay, what the heck is going on with my phone? Weird. Anyway, so this will be basically the same idea as over here, this loop. So I can even reuse that. So position is 0. Well, actually, that's really bad code. So let's not do that. Okay, let's just use I as a iterator. But this is not I, right? Next bit this is I. We are getting the next bits out of the set, yes. So we iterate over all the bits in the set, and then for each orthogonal I minus 1, we want to prune the number, but we need to be careful because we only want to remove it from the positions that don't involve the columns or rows that we care about, right? So let's go back to this example, right? So like, let's imagine that, okay, I will not do the entire grid, but let's work with this. So let's imagine I have pencil, right? This situation, so this would be like an X-wing, right? So the top and this row, these two rows form X-wing over 9s. So in this row the 9 can be only here and here, and then down here it can be only here and here, right? So this tells me that in this column I can remove the 9 from here, but I need to be careful because if I just call like remove all the 9s, it would also remove these two 9s, that are actually part of the X-wing. So that we definitely want to avoid. And how I can actually do that is I can tell it to prune the number, but actually please do skip over iter. So again, iter contains the bits that correspond to the blocks that I want to remove this out of. Sorry. That I don't want to remove this out of, because these are part of the fish, right? So iter has the positions of these blocks, set has position of these blocks, and that way stuff just works. Why is this complaining? Orthogonal, what do you not like? Expression must have a class type. The what? Okay, I really don't get... Oh, yeah, brackets, right? Yes, okay. Wait, what? No, not brackets, that was correct. Okay, I will come back to that. I'm not quite sure. This needs to be pointer. But why is this then complaining on this? That was so strange. Okay, anyway. Very confusing underlining. Yes, okay, so now it's correct. Like, this doesn't have a method prune, which is totally correct. Okay. And I mean, this is it. So we went to this from this, and this is not even all the code. This is actually just part of the code, because this is also calling the generic non-recursive find function. So I'm so glad I decided to just spend time on refactoring this stuff, because this is just crazy, like how simple this code is becoming. And I'm hoping it's also easier to understand what the hell is happening, because previously, because there's like callbacks and whatnot, I can imagine this was really hard to read. I mean, it's still hard even to me to read it right now. Like, I'm looking at it and I'm like, what the heck is happening? So yeah, very cool. So we need number positions method and we need prune method. Okay, I will just take a very, very short break because I kind of started at the last minute and I need to take care of a couple of things. But like a 2-minute break, I will be right back. Okay, and I'm back. Right. One thing I actually forgot to mention is the previous way I implemented this, which kind of is generate all the like find all the patterns and then try to remove things from the puzzle, basically. That had a massive problem because what actually was happening at some points I was actually removing too much stuff out of the puzzle, because some of these rules kind of overlap, and if you overlap them, you can end up with a corrupted puzzle. But because now this is kind of done in an iterative way, where we basically like try a set and then, you know, remove stuff, we are always kind of working with the live state of the puzzle. So because of that, this problem should be gone, completely gone. So I'm so looking forward to putting this in, because this will simplify things so much. But yes, okay, we need to write the number positions and prune. So that was in the not generic block, unique block, right? What do you have against vector? Yeah, there's something fishy going on with includes. I'm not quite sure what's happening. Okay, so number position should definitely return a bit set, and the number that we want is just, you know, parameter of this, and here we just want to loop for from 0 to size. And then if the element has is bit set on the number, then we want to insert this into the bit set. So bit set result, we'll start with an empty max, and if this is true, we want to do result plus equals I plus 1. So we set the bit that corresponds to the ordinal number of the element, and that's it. We just return result. So this is the number positions, and then we need the prune. So okay, so this is definitely const, and this is also const, and this should be no discard for sure. And lm.size should definitely be no except, so this also should be no except. Over here, this should also be no except, because we keep iterating until the size, so there's no way there's like a mismatch of indices happening over here. And that definitely should be also no discard, because otherwise, like, why would you call it? Okay, so then the prune. Wait, prune. It was a number and then a byte list, right? So unsigned number and then a byte list with a bit set. And let's be politically correct, let's call it skip. Right, this one should also be, yeah, this one also should be no except, because we will just iterate over stuff. Yes. Okay, So the same kind of loop over here. We just go. What the heck happened? That was a bit strange. Still can get used to the Visual Studio Code. It's like it's close to what I want, but it's not exactly it. Like for next week, I definitely want to have remote access to the machine with VNC. That will be so much better, but I just didn't manage to do that this week. So yeah, like this is remote development using SSH, but it's not. It's almost there, but it's pretty awkward still. Right. So what are we doing? Okay, so if this is not in skip, so if skip.isBit set I +1, then just continue. So if it's in skip, then just skip, right? Simple. If it isn't in skip, then just lm I dereference the thing and do minus equals I +1. Not I +1. What am I doing? Number, not I +1. Okay. So from everything that's not in the skip, just remove the number. And that's it. Okay. So then this should be now happy. It is. Okay. So I guess we do have a solve fish method now that should straight up work. So let me just get rid of this out of here, because these are just copies of the stuff from the other place. And now we should be able to test it again. So we did have the test here, the Sudoku algorithms test, right? Okay. So this will be the solve fish. And yesterday I was looking at this and I remember we had some, yeah, so this is the finned fish test. Okay, so this is one of the X-Wing tests. Okay, so you can just take this over to here, and I will need to call it slightly differently than I did over here, but that's fine. So we start it with a Sudoku puzzle. Okay, so that's a bit tricky because that kind of means I need to basically refactor Sudoku for this to work, which is a bit awkward. I'm not there yet. Can I do something simpler? Maybe I can. Okay, let's think about it a little bit. So we basically want the two-dimensional array of bit sets, and then we need the columns and rows. Yeah, okay, so it's a little bit awkward, but okay, let's work with this. So I can, yeah, I think actually let's just make it one-dimensional. So let's have a vector of bit sets, right? So this will be our data. Then we will have vector. So here I must have the vector of vectors because I don't think I can. Well, it's not really vector of vectors. It's a vector of blocks, right? unique blocks. So I will definitely need that. I will need to have a vector of, somehow need to fill the blocks, but yeah, okay, not there yet, but we'll need to do something. Okay, I will definitely need like unique block rows, std vector unique columns. Right, so I create the rows and columns over here, and then I just have the pointers to those, because that's what the actual algorithm works with. It works with pointers to the blocks. Okay, so one thing I didn't do yet is figuring out how the heck do I make this work. So I think in the Sudoku puzzle, like in the Sudoku class, I mean, I just have a pretty hard-coded loop, if I remember correctly, somewhere. Reset. Yeah, something over here, right. Yes, so we create the row by grabbing the stuff out of data. Okay. So now the question is, how do I do it? Do I just put a constructor that takes this as its parameter? Probably, right? Like, is there... I don't think I want to have something like a pushback. Although, to be fair, it wouldn't really matter for right here, because the initialization should really only happen once. So I could kind of have whatever is convenient, right? Like, I don't really... This is nowhere near the critical section of the code. Although maybe it is, because I just remembered, for the killer blocks, one of the solving techniques was actually to dynamically create new blocks as we go, to basically look at a killer block, and if it contains like a sub-block, then just get rid of the, you know, the outer block and just create the complement. Because once we have the situation, we kind of know, okay, like the sum of this thing is 10, for example, right? And the sum of the outer block is 22, well then the remainder is 12. So I can kind of dynamically create these extra blocks for the complements. So then it would kind of be in the critical section of the code. And yeah, like, basically what I'm... Okay, now I'm leaning more towards just like taking this basically vector move inside here, right? Because no matter what I'm doing, whenever I'm creating this block, I always know how big it is. I know there's no situation where I don't know how many elements I'm actually creating this block with. Because that would be super weird. Like, you know, I have a solving technique that just like takes a complement somewhere, right? Well, I know how many squares are in the complement, obviously. So the code that's actually creating the data structure, the vector, can do that very efficiently because it knows exactly how many elements are in the vector. So I really shouldn't kind of offload that inside of this thing. It should really just take this as of the constructor. Okay. I just convinced myself this is the best approach. And hopefully this was reasonably easy to follow. If not, you know, as always, feel free to interrupt, feel free to ask questions, like I'm super happy to answer anything. And if you're watching the recording, of course, you cannot ask live, but you can always ask in the comments, and I will endeavor to answer if it's something that I can answer. Okay, so this will just straight up be lm std move on, and max is max. So we are just taking it as a value because it will get moved into, and this is exactly what we want. Cool. So yes, then in the test, what I can do, it will still be a little bit awkward, but I can do it. Okay, so the data okay, so the data I just straight up want to initialize with so the data I just straight up want to initialize to be 9 by 9 of bit set, and I don't have code completions again. Why is this happening? Why? I really don't know what the heck is wrong. And this is really the reason why I want to get rid of the Visual Studio Code. Like, I can handle, you know, basic editors that don't give you any code completion. Sure, like, you know, I can handle doing stuff myself. But if there is like a situation where it's like inconsistent and it works for the most part, but sometimes it doesn't, it just keeps annoying me to no end. Okay, so now we will need a loop. Yes, so we need the loop for the rows and a loop for the columns. Right. And okay, we need this because we need to actually store the data somewhere, but that's really what the only purpose this blocks variable is serving. It's just keeping the stuff on the stack. Well, I guess on the heap, but whatever. You get my point. It's just keeping this stuff around. Okay, so for all the rows, so this will be int I less than 9, I plus plus. Thanks for the follow. Hickle C1, or how the heck do you say that? Okay, so for all the rows, for all the columns, and these loops will be very similar. It's just like flipping around the ij in the indices. Is my chat actually working? Because the weird thing is I got the alert in my video, but I should also be getting alerts in the chat. Okay. A bit suspicious, to say the least. Let's just quickly double check this. Interesting. Okay, anyway, I will just keep going. if you are seeing the video but I'm not responding to the chat messages, please try to say again something in the chat, because I don't think I'm missing anything, but it could be that I am. Right. So again, so this is for all the rows. So this will be data I times 9 plus j. And what we want to do, we want to have a vector, std vector of the bit sets, pointers to the bit sets, right? So this is our row, and we just want to do row dot pushback pointer to this. So after this loop is over, we have the row, so we just create the bit set, so blocks dot emplace back with the row, and we actually want to move it, and the max, which is 9 in this case. Right, and because this is a row, we also want to actually put it straight up in here. So I want to actually move this up front. So this will be rows dot push back. I could do emplace back, but for pointers it really doesn't matter. Blocks dot back. So this is the last element of blocks, and just get a pointer to that. One thing I need to make sure, because I'm grabbing the pointers over here, I need to make sure that there's no reallocation of the blocks. So what I actually want to do over here is blocks dot reserve 18, because I have 9 rows, 9 columns. That's good enough. So yeah, then these pointers that I'm grabbing over here will be stable. Right. So this will be the column, and this will actually be exactly the same code. But now we are iterating over the columns in the, in a loop. So because, the two loops are switched, this will just straight up work. And unsurprisingly, this will be literally the same code, except of course I need to put it into the columns instead of the rows, and that's it. Right, so now I have rows, columns set up correctly, everything is fine. So this thing doesn't really change, because this is something I definitely want to do. So data I times 9 plus j, I just remove the 4 out of all the bit sets. And then I have this craziness. Okay, so that still remains the same. Okay. Okay. And I just need to change this, so times 9, and I will not simplify these expressions, it's just to make it, explicit. And I'm definitely looking forward to, like, when C++ will have proper multi-dimensional accessors for arrays, which is a thing that's in the pipeline. But, knowing C++, when exactly we get that is a completely different question. But yeah, like, not having to do this will be so nice. And I'm sure you can make it work right now with like span or something, which technically I could actually use, because I'm switched to C++ 20 now, so maybe it would even work, but I mean, this is a test, so nah. Can't be bothered. Okay, so now we have the solve fish from Sudoku algorithms, right? So the solve fish takes the blocks in one dimension and then the orthogonal, and then, right, So in this test, what we are looking for, we are looking. So the fours are. We have 2 fours in row. Okay, let's just look at the picture. I think there are even multiple ones or not. So there's a. This row is nothing. Oh, so this is actually single. Oh, this is convenient. I can just select the 4 and choose me the first. Oh, okay. Neat. Right. Okay. So these 2 columns definitely form an X-wing. Yes, that's it. Right. So because the comma operator is going away, we can finally have in C++23 or maybe some future version the multi-dimensional access operators. Yeah, I knew there was something specific happening in C++20. Thanks for the comment. Right, okay, so this is the X-wing. It's over columns. So the first dimension is columns, the second dimension is rows. And I think that's it, right? There isn't like an extra one. Yeah, that should be it. So I want solvefish with cols, rows. Oh damn it, what were the parameters again? My short-term memory is so freaking horrible. Okay, size 2, number 4. But I mean, I even have that on the next line. What am I doing? Size 2, number 4. Okay, so solvefish, and then if I go over the data, yeah, so this should be still the exact same logic. Times 9 plus j is possible 4, count them, and then this is just like hard testing if we accidentally didn't remove this one. I think that works. So let's just run this test. Oh, we don't have the is possible anymore. We have the is bit set. Right. So that's one thing. And then there's a bunch of complaints about other stuff. So what am I doing? Comparison of integer. Oh, where did I write int? Oh, sure, yeah, this should be size t. Well, okay, let's make it unsigned, that's good enough. And it will not collide with my other stuff. Okay, unsigned. That should be good. So unique block comparison of, oh, I did that even here. Why do I keep doing that? I don't know. Yeah, that should be good. Or maybe not. 20, yeah, one more. Okay, so let's try again. Oh, interesting. So it's actually breaking our puzzle. So let me have a look at what's actually happening here. Right. So let's highlight the force again. So I said this was an X-wing, which is true. This row, okay, let's just look at the columns. This is a singleton, this is a singleton, this is a singleton. This... okay. There is a thing here. So it kind of depends on which order we do things. So if we find this X-wing first, this 4 square one, that will remove this 4, right? but that will actually make these two columns an X-ring again. But that actually shouldn't remove anything out of the puzzle. So, okay, there's definitely something broken then. Because we definitely, so 9 would basically mean we just found the final positions of those numbers, which I don't think is possible. So okay, we need some debugging. Which is annoying to do in check, because this is one thing I really hate about this framework. It's like, maybe there's a way to get around that, but if you basically add like extra information, it will get like attached to the next require that fails. But this is actually very interesting. So it is very explicitly it's the count that fails. It's not, this one is actually okay. So it, okay, but okay, we are, yeah, so we are checking if it did remove the 6-3. So 6-3 would be 0, 1, 2, 3, 4, 5, 6, 3. So this one, right? So this one got correctly removed. So that's definitely correct, but that should be the only one that got removed. I think like there isn't really, yeah, there's like nothing extra overlapping, so I'm interesting. I'm not quite sure why it would remove stuff. But I guess we can check, because last time I think the debugging actually did work at the end, so let's see. Yeah, it did. Oh, this one I don't care about anymore. Right, solve fish. So I want to go inside of this function, and actually I care about specifically this branch. So I want to see when the set count, well actually let's break on this line. So when the set count actually is the same as the size of the thing. So let's just continue. Okay, so we are inside of here. This is straight up saying we'll be removing something. So what is the set actually? So the set is 66. Let's grab my calculator, switch from scientific to programmer. So 66 is number 2 and what? 2, 3, 4, 5, 6, 7. 2 and 7. Okay, so 2 and 7 in this puzzle. And we are looking, so these are the positions in the column, so these are the rows. Okay, so 2 and 7. Let's go to the test. 2 and 7. So 2 is this one, and 7. What the heck? 7 is this one. That's definitely weird. Let's go back to the here. Let's look at what was iter. So we're looking at 17. 17 is 1. 1 and 16, which is shoot. 5, yes. So 1 and 5 columns 1 and 5. Columns 1 and 5. 2, 3, 4, 5. Okay, this is 100% wrong. So how the heck did we end up in this situation? So the thing is, column 1 should not appear at all because that one only has 1 4. Yeah, or from this one. So how exactly are we ending up in this situation? This is quite interesting, I must say. Where's my function? Okay, so let's just double check if we are doing the correct thing. Oh yes, the damn it. Yeah, this condition is wrong. Yes, because what's happening is I'm skipping over the columns or rows that have like only one thing set. But the problem is I'm still unioning the other stuff. And that's wrong. I should skip over this entire candidate, basically. So basically what I need is something like valid equals true. And if it's less than 2, then valid equals false. Yeah, so I can do the or always, that's not a problem. And I guess I don't actually need this then, so I can do straight up this. Okay. And actually, let's just break out of this. So if we run into a row or a column that has only one possibility, just get out of this while loop, this internal one, and then over here what I need is if not valid, then continue. So just keep over this entire candidate. Okay, and that should work now. I need the X. I do need the X. Yeah, but that's okay. And I guess I'll just put it below the if. Doesn't really matter, but yeah. Okay. Still failing. How the heck is it still failing? Okay, let's look at it again. Right, continue, and this should. What the heck? Oh, it's not failing, it's just never finishing. Yes, because I cannot do a simple continue. Oh, what am I doing today? Right. Indeed. So, okay, let's. Yeah, we are kind of back to what I wanted to do anyway. So, I wanted to invert this logic so I can kind of unindent this piece of code. So let's do that. So if invalid or this is not the same, then what you should do is go to the next iteration and then continue. And this can now be unindented, removed, right? Such a silly mistakes, but yeah, that's the stuff that happens. Now it's passing. Okay, perfect. And I had more of these tests, I'm pretty sure. So let's quickly run through them. So this was this one. Okay, I have another saltfish over here. So let's just do that. Oops. Where does it actually start? Yeah, over here. Okay. Right. So let's. What? Okay. Weird scrolling happening for some strange reason that I don't really understand. Okay, so this should go over here, and I need the headers again. Okay, let's call it Solfish X-Wing 1, and let's copy this. Okay. Where did it? Oh, here it starts. Okay. So this is X-Wing 2, I guess. Yeah, we are still doing size 2. Okay. So, right. So I guess I should actually make this like a helper thing that I will just reuse, because this thing that sets up the rows and columns, this will be reused in all the tests. So yeah, let's just make a very quick thing. So anonymous namespace over here, so we don't expose stuff we don't want to expose. So this will be test puzzle. Okay, and its constructor. I will do all this work, and this just needs to move inside. And now this just happens in the constructor. And I guess this can be private now, so the data can be private. No, data cannot be private because I want to monkey with that. But I guess blocks can be private, but I mean, okay, there's no reason of doing that, so let's not overcomplicate things. So blocks will be reserved to 18. Oops. And then I will have, yep, these two for loops. Just move them over to here. And I mean, that's it. So now all I do is just take this and mini, what I call it, mini test puzzle data. No, let's call it puzzle. Mini test puzzle, yes. And the thing that need to change is just all of these are puzzle.data now. Okay. Okay. Same over here, and the same over here, and that should still work. So now what I can do over here is just mini test puzzle. So this is already preset up, and now this loop can be puzzle.data 2 times 9 plus j, and puzzle.data 5 times 9 plus j. And then, yep, the solvefish remains kind of the same, but now I just need to figure out, we are doing, okay, so j is the column, so I'm removing from rows 2 and 5 once from all the columns except for column 2 and 6. Okay. Or I guess 3 and 7 because this is 0 based. So this means that I want to, because the numbers are missing from the columns, I want to do columns and then rows. Okay, so date puzzle dot calls puzzle dot rows to 1. Okay, that should be correct, I hope. So puzzle.data times 9 plus j, puzzle.data I times 9 plus j, and is possible needs to change to is bit set. Is bit set. Okay, let's see if this works. Doesn't. Okay. Class mini test puzzle doesn't have any field name that. Okay. What? Okay, something weird happened here. Where is this? No, that looks correct. There shouldn't be a comma there. Okay. Was that it? Just a stupid comma that got in? No, there's some other complaints still. Okay, let's rebuild so I can see everything. Oh, yeah. Okay, it's data.calls and data.rows. Indeed. Not puzzle. Puzzle.calls and puzzle.rows. Indeed. Okay. True is not true. Okay. So what's wrong over here? Like here I would suspect more that I have something fishy in my checks. Okay, so here I'm checking if I'm in the column. Why is this 5? Because this is 5. Okay. So if I'm in row 2, did exactly the opposite thing, didn't I? And I even said it correctly, but did it wrong. Damn it. This code is removing the number 1 from rows 2 and 5 from all columns except for column 2 and 6. So if I'm looking for the X-wing, the X-wing will be over rows because it's the rows that are missing the numbers. And then I'm removing the numbers from the columns, so it should be rows, columns. I said it correctly, did it wrong. Yes, now it passes. Okay. Amazing stuff. Right, but that was this one. And I think there's one more. Yes, one more. Okay, cool. Let's just take it. Okay, and let's copy this thing over here. It's a bit of a shame that like all my tests are basically just X-wings, but I mean, to be fair, this is testing the code like well enough anyway. Like I will need to at some point actually have a proper look at my test coverage. The problem is my test coverage has been broken since the start. I don't actually know why. I wish I knew, but there's just something weird going on with the continuous integration, and it just doesn't seem to like set the correct file names or something. It's really strange. Okay, but let's just finish this. I times 9 plus j, because yes, like one thing I really want to have is like a proper test coverage for this, because I already run into situations where I didn't have proper test coverage and I literally spent like 4 hours, the entire stream, just debugging the thing and looking for like 1 bit change. Literally like 1 bit was off and I couldn't find it. And it was just driving me nuts. So yes, like I definitely have the goal of cleaning this up. Okay, so let's look at this again. So we clean the 4 from everywhere. Okay, so this is easy. And then we reintroduce it. Then we reintroduce it into rows 6 and 1. But what we actually want to do, so the X-wing is actually over columns, because it's columns 4 and 6 that together have only 4 possibilities that overlap in the rows. So the thing that should be removed is the row 6 column 3, or row 7 column 4 if we are counting ordinals, but you know, you get the idea what I'm talking about. And that's actually what I'm testing down here, is that if this thing was removed. Okay, so this should be then over columns again. I just need to keep repeating this so I don't screw it up again. So columns, and removing from rows, size 2, number 4, and this just needs to change. Times 9 plus j is bit set, and the same over here. Plop, times 9 plus 3 is bit set. Cool. Okay, perfect. Stuff is passing. So we have the fish rules, which means I can get rid of a bunch of code now. This was actually on the Sudoku, right? Yes. So basically, instead of this thing, that will be right Sudoku solve fish size and number, so that remains the same, but now it will be straight up just solve fish with get row blocks, get call blocks size number, and then the exactly same thing but just inversed these two things. Okay, that looks so much better, and yeah, there's a bunch of cleanup I need to do, but the code should be all correct. Okay, so it was this big thing, then recursive find fish is another thing that should disappear. That one was actually in the block checker code, if I remember correctly. Yes. Okay, so this is another big chunk of code that goes away. Very good. Okay. So now for the complicated stuff, now for the faint fish. So this is like one of the most complicated things I so far have in my solver. Especially to kind of mentally envision. So can we still do this using the sets? Okay. Yeah, okay, before I start with that, I will just take a very short break, and once I come back, I will look at the recursive faint fish. But yes, this thing is a beast, and if I can simplify this, like, I would be so happy. Like, this refactoring has already been exceedingly successful. I'm so glad that I started with this, because the code got so much simpler, but this thing is a beast. And if I can simplify this, this would be, oh, brilliant. Okay, see you in 5 minutes. Okay, and I'm back. So, had a little bit of fruit, so now I should be pumped up with carbohydrates again. So let's get into it. Okay, so finned fish. So this thing is a beast because, like, even explaining this is pretty hard, but actually implementing this rule is a freaking nightmare. So what is happening basically, like, if I go back to the, okay, let's just like recreate a very simple X-wing, right? And let's imagine that the 9 is just missing from everywhere, right? And then if I just have the 9s, you know, over here, basically if we have this kind of situation, just to make it, you know, slightly more interesting. But basically, you know, since if I look at row 2 and row 5, no, 6, sorry, row 2 and 6, the 9 is only in the column 2 and column 8. Well, then obviously I can just remove all the other 9s, you know, that are here. However, I can also do certain eliminations if I still have this kind of situation, for example, right? So this is almost an X-wing. If I look at the row 2 and row 6, the only thing that's extra is over here, right? Well, if you kind of think about it, for these 9s that share the block with these two numbers, either they will get eliminated by the X-wing, especially, I mean, specifically these on the column, these two, right? It really does only apply to these two. So these two 9s would get either eliminated by the X-wing, or if the X-wing isn't true, because we still have these two options here, right? Like, it either can be the X-wing, or the 9 can be here, in which case it's not the X-wing. But this 9 would also eliminate these two numbers. So if you kind of have this X-wing that has a fin, which is this number, you can still eliminate something. You are eliminating usually only one or two things inherently, because, you know, it needs to be something that's sharing the block, and because there are only 3 numbers, you know, on a column or a row in the block, at best you are eliminating 2 things. Usually you are just eliminating 1 thing, but this can already give you a massive boost. Like, if there's a lot of puzzles that just get resolved by this weird thing that just allows you to remove 1 number from 1 square, and then it's all like unravels basically. But implementing this is interesting. Let's just put it that way. So, okay, I need to kind of remind myself what the heck I'm actually doing here, because yeah, this is a crazy thing, right? So I'm still doing the number positions. Yeah, okay, so I'm still accumulating the number positions across the rows or columns, right? Then if I'm in a situation that I have one more positions than I need, basically, then I go over the positions right. Okay, so what I'm checking here is that I don't have this kind of situation, so I would have a 9 here as well, right? Because then this doesn't work. because this is simply 2 rows with 3 positions, and these two things are kind of, you know, symmetrical to each other, so you cannot really decide which one is true. You really just need to have like one thing. Otherwise it doesn't work. So I'm trying to look if when I have one extra position, basically over here, is this a thing that's only from one row or column, right? Because here I count, like, look at my set and try to figure out who has a number at this position, and if it's only one of the rows or columns, then I set this to true. Okay. Does that actually work? I mean, it didn't break my solver, so it inherently has to work at least a little bit. I'm trying to kind of now double check my, like, all my logic when I'm refactoring this code. Right. So can there be like a weird situation where this would be, well, okay. So if I have the situation that I have one more position and one of the blocks has that position exclusively, then inherently if I remove that from the equation completely, right, I have the set size equals positions.size, and I have an X-wing, or sorry, I have a fish, right? So because of that, this has to work, because I'm basically isolating the extra fin here. I know exactly which of the rows or columns has it, and if I would remove it, I know for sure that this would actually be an X-wing. Yeah, okay, I think this is correct. And I keep saying X-wing, I mean fish. X-wing is just the size 2 fish. Technically X-wing actually isn't a fish, it's a wing, which is a different type of rule, but all these Sudoku rules kind of intersect on things, so you have different names for the same thing many times. Okay. So this is correct. So what do I then do with this? So this, I suspect, should be used references, right? So this should be used in the Sudoku. Yeah, okay. So, oh come on, this is just an overlay that closes. That's so annoying. Okay, soft fin fish. So I find all the potential fin fishes. And then what I'm doing with those. Okay, I'm trying to figure out if this is a true fin. Okay, so that's another thing. So one thing, if this 9 wasn't here, right? Let's say the 9 was here. Then I still kind of, when I'm looking for, you know, like combinations that work with the fin, this would still pop up, these 5 squares. Because there's one extra, if I remove it, I have a fish, everything is fine, right? But this is not a fin, because like it doesn't share the block, like there's no intersection that I can remove. So I really want the extra piece to be with one of the elements. Okay, and if I remember, this was exactly what this thing was just doing, right? What the heck is this function doing? Pregnant. Number positions. Well, the benefit I have now is that I actually can remember the fin, because yeah, here I kind of forget what the fin was because I just get again the results, and those just specify either the set of rows or set of columns that are interesting, and I need to kind of reconstruct the information. And yeah, this is just like a nightmarish piece of code. But I think I can simplify this quite significantly, because if I know what the fin is, the condition I'm looking for is that the fin is sharing a block with one of the numbers. In the fish. And since I still know what the fin is, I think I can do that check pretty easily. Okay, let's try to... I will not look at my previous code too much, and I will just try to rewrite this, because I really suspect that a lot of the complexity here was kind of forced by me throwing away the information and then having to kind of reconstruct it from the ground up again, basically. So let's just try to redo this in a simpler way. So I will just basically use this recursive find fish find as a template. Because this is still valid, like this approach is still correct to finding the fin. The only thing is, yeah, basically over here, if I'm looking at the position P and I figure out that the count is 1, I need to remember that as my fin, because that's the information that I can then use later. Okay, let's do that. So, going back to the Sudoku algorithms. So this one will be one step more complicated, because now I need like the founding direction, which is the blocks, then I need the orthogonal ones, but I also need the 3x3 squares. So I guess that I will just call squares. The squares, do I need them? No, I only need the orthogonal ones for right axis. The squares I just need to read. Okay. So let's just call it squares. Okay. So find fish, right? And yeah, this is probably the most complicated thing I have so far in my solver. And maybe I can simplify it significantly that it ceases to be the most complicated thing, but like right now, no discussion, this is the most complicated thing that's in there. Okay, so the basic idea remains the same again. So we have the set with num elements and the size that's still exactly the same thing as always, and we just loop over that, generating new set in each step. And then over here, right, with this to get the next iteration. Okay. So right, this piece of code remains the same with the fish, because this is just figuring out the number of positions for this number, and we have the same kind of less than 2 constraint, so everything is cool, right? So but I will now, this will be slightly longer because of these things need to happen in multiple steps. Right. So if it's not valid, as in one of the rows or columns that I'm looking for did have only one instance of the number, then just go away, go to the next set. If the count of the positions for the number is not size plus 1, we also don't care, because in this one we are just looking for the finned fish. Even if we would find a fish like this kind of relying on the fact that, like, there's other solving techniques running, and this is really just looking for this specific case. So in here we know that we have a finned fish, but maybe the fin is useless. Well, actually, okay, I'm jumping the gun a bit. We know that we have something like a finned fish. We need to check if the fin is, if it actually has a fin. Yes. Okay. So this is the case where basically we would end up with size plus 1, but it's badly distributed across the columns or the rows, which would be bad for us. So here I need to basically find the fin, which was happening in the where did I lose it? It was over here, right? Okay, so that's this piece of code that I need to rewrite. And again, I actually don't super want to look at this. I will just rewrite it from scratch, right? So the set is the set of rows or columns, right? No, sorry, the set is actually the positions of the number. Okay. So I want to loop over the set. Yes, I want to loop over the set. Okay. So loop over the set. And now I need to figure out how many of the rows or columns out of iter have this number. So this will be, weirdly enough, this will be an inside loop. Yep. So while j, but now here we go over iter, And I'm kind of thinking I will need to write some... Oh, this shouldn't be bitset, it should be unsigned. Unsigned 0. Okay. And yeah, I'm kind of already thinking that this needs a bit of helper function or something. Right. So here I want to check, I want to count. Yes, so I want to count how many of the rows or columns that I'm looking at have the number. So if where the heck is it? Blocks? Yes, blocks. If blocks j minus 1, right? Yes, j minus 1 is bit set number. So if this thing has the number at this position, no, something is wrong. Okay. Go over all the rows and figure out which of them have yes, because this is yes, okay, so this is the block down on this number positions for the number dot is bit set I. Is this correct? So number positions returns a bit set. Okay, I need to visualize this a little bit. So in my iter, I will have 2 and a 6. Then in my set, I will have 2. Let's revert to this situation. So I will have a 2, 3, and an 8. Then if I do blocks j, so this will go over each of the blocks, right? Number positions, so this one will number positions return 2 and an 8. Is bit set I, so I, yes, okay, so this is correct. This is the I from here, which are all the positions that I have found. So if this is set, then count plus plus. Yeah, okay, this code is really nightmarish. Like this one particular rule is really nasty. So okay, so for I equals 2, I should get a 2. For I equals 3, I should get a 1. For I equals 8, I should get a 2. But now what I really care about is if count equals 1, so this is the potential fin. I want to oh, okay, I know I, which is basically its position. Okay, perfect. I want to remember I. Okay. Well, actually, if I just do break, yes, so I break out, I remains at the position where the fin is. Okay. Oh my god. We know that the fin is at position I. Now the interesting question is, can I actually also remember which of the blocks it is in? That's actually much harder, because my first intuition was just, you know, check if it's the size plus 1, right? The number of positions is size plus 1. The problem is that that's not necessarily correct, because again we can have this like staggered thing where, okay, let me just quickly do it with just very simple visualization, right? Like if I have 1 1 1, this would be the fin, right? 1 1. It doesn't necessarily have to be like this. It could be 1 1 1 1 1, and this can be, yeah. Oh, come on. So I can have basically this kind of situation, and I guess like this, right? So, oh shoot, is this actually a valid fin fish? Oh damn it, it is. Oh, this is annoying. I just realized that. Okay, I just found like a proper bug in my code. In my old code, I mean, not in the current code yet. Oh, this is annoying. Right. So this is a fish, like these ones together, not counting this one, right? So everything except for the highlighted one. This does form a fish across these rows. Why? Well, because if you look at the positions, yeah, serious coding time. And welcome back. It's like today is actually going great, and I just discovered I actually have like a solid bug in my previous code, the before refactoring code, and it's actually a very neat bug. I totally understand why I made this mistake. Funnily enough, I'm not sure how to fix it. But okay, we need to figure out something, right? So, looking at these 3 rows, they have 3 columns where the ones can end up, right? So this is a valid fish. This would be a fin of this fish, which means we could remove basically, oh, this is horrible. There's kind of like a virtual one over here. This is a nightmare. Because I like, if the one was here, I cannot remove it. But I can remove these 2 ones from here. Oh man. Okay, this is like proper nightmarish. How do I do this? Well, okay, so one simplification, like I can ignore the virtual one, because it's either there or not, it doesn't really change the fish. If it was already removed and this is still a fish, then it's fine, and I like, even if I would like go and remove it, nothing breaks basically. So good. So okay, I still need to figure out where exactly the fin is, which is this one. and then I need to look into the intersection of the 3x3 block and this column. So I need to figure out which column of the fish intersects with the block that contains the fin. Okay, that's the correct way to do it, but how the heck do I do that in code? Oh my god. And yes, like basically in my current code, it would completely ignore this situation. I like totally am ignoring this version of the finned fish, because I only consider the fins that are sharing the 3x3 square with part of the fish. But you can have this like weird, like disjoint fin that's in a different 3x3 square, and I absolutely didn't realize that that's a possibility. Oh jeez, this is amazing. Okay, so this code is still fine. This code checks if we have a fin. We know the position of the fin, so in this case, so we were looking at the rows, so in this case we would figure out that the fin is at position 3. Can I somehow remember which row? Actually, I kind of think I can. Well, because the thing is, finned fish already is extremely rare. So I kind of made a very rare situation a bit more rare. So it's not like I didn't really cut off too many puzzles with that. And honestly, before I implemented chains, my solving success rate wasn't that amazing. Like it was still 90%, right? Like it was pretty high. But what really took me the last mile was the chains, because those are super powerful. But yeah, like this is, and you kind of need to realize that this is really just at most removing like 2 possibilities out of the puzzle if you actually find it, and finding this is already super rare. So it's a rare situation that only removes a couple of possibilities out of the puzzle. And I kind of made it weaker, but But yes, I kind of imagine once I finish the refactoring, the percentage of the solves will be actually higher. I think that will be the case. So okay, let's do a thing over here. So when we do this, let's always override the block ID with J. And if we have the situation where count is 1, then obviously this only happened once, right? So then block ID has to contain the block of the fin. So actually then the block ID should be over here, right? Ah, what the heck happened? That was a weird copy paste. Right, so okay, perfect. So now I know that block ID has the ID of the block and I has the position inside of the block. So I know exactly where my fin is. So my fin is at position block ID I. Perfect. So now I need the code that figures out what is the intersection, basically what is this area, like this 3x3 block, get a block that contains the fin and figure out which squares are intersecting between this and the fish. Okay, but that requires a bit of reverse lookup, which I don't have that information right now. That's kind of annoying. How can I do that? I'm passing in the squares, which are the 3x3 squares. But to figure out which one actually contains the fin, I would have to literally just linearly search through everything, which is really bad. So I kind of need a reverse square lookup. So yes, like previously this was inside of the Sudoku class, and this one has like get something by something, maybe not, does definitely have some form of reverse lookup. Anyway, but since I moved it out, not to here, to here. Okay, how do I do this? How do I do reverse lookup of the square? Or I mean, I don't actually need that specifically. What I kind of need is a way to just get the intersection. Yes. So basically, I kind of want a function that takes in the coordinates of the fin, the list of columns of the, I keep calling it columns, it's not necessarily columns, but for now let's just do that. List of columns of the fish, and returns an intersection. Yes, actually, I basically want to have a prune function that does that. So prune coordinates of the fin. Well, first of all, the number. Okay, so the number coordinates of the fin, and list of columns of the fish. Right. So this would be like unsigned per unsigned, I guess. And then a bit set. Yeah, I think that makes sense. The only tricky part here is that I need to somehow remember which direction I'm looking at, because this is a directional rule. So that's why I have blocks and orthogonal over here, because you can pass in the rows and then orthogonal is columns, or you can pass the columns and then orthogonal is rows. Am I actually using this though? I am not. So this will literally just be I could pass in rows and columns and then just call the correct like prune based on the coordinates and handle this internally. Okay, I think that makes the most sense, honestly. So I basically need yeah, kind of a helper function over here to extract this big loop, and oh, then I just need to pass in a lambda or something, but that makes it I was really trying to avoid like callbacks. Yeah, I was really hoping that I would avoid that, but I guess there's no... Yeah, I can't really replace them. I mean, I could just copy this code basically twice and that would also solve the problem. I mean, solve the problem, it's not really solving it, right? It's just creating a different one. Yeah, I think that's... the lambda is honestly, I guess, the only option I have. If I don't want to basically double the code. Yep. Okay, let's do that. So instead of these two things, I want to take an std function that can be void, that's fine, but needs to take basically what I described down here. So it basically needs to take the same thing as the prune, and it will just like correctly swap it for the directions. Okay. Yeah, so this will be just called prune. Okay, so then basically over here I just do prune of number, coordinates of the fin, which will be well, I guess I can just... I don't need to have a pair. That actually be cleaner. Let's just do it like normal parameters of the function. And then the bit set will be... okay, which one is that? So the positions of the numbers, that's in set, yes. So set, oops, set. Okay. So instead of std pair, let's just make it unsigned, unsigned. And I will need function over here. And I guess it should be a const reference to the function. Okay, I think that's it. Okay, let me just condense the comments on this. So we know that the fin is at block ID I, and set is the list of positions for all the numbers. Okay. Right, so now calling this will be a little bit tricky, but that's fine. And let's see if I can then make it work in my test. So I did have, yeah, so I have some tests for the finned fish. And because I have just thought about the, yeah, I have actually multiple tests for the finned fish, cool. Well, so since I have thought about this weird scenario, I also want to replicate this particular scenario in a test. And see if it works. So let's copy these two tests first. Amazing stuff. Like when I started this refactor, I was kind of expecting that I would find some bugs somewhere, but this I wasn't expecting this type of bug. Like, this is kind of amazing. And the funniest thing, it doesn't really break anything, it just makes the solver worse. Oops. Fun times. So solve finned fish. Okay, one. Finned. Let's just call it finned. Right. Right, okay, so here I actually work with an yeah, I can do that. So mini mini test, what did I call it? Mini test puzzle? Mini test puzzle, yes. Yeah, so let's just do mini test puzzle test and mini test puzzle expect. So I'm gonna get rid of these two. Okay, so this just becomes a little bit more complicated. So data times 9 plus j. Oh, my typing is really bad today. Expect dot data and expect dot data as well. Times 9 plus j times 9 plus j. Cool. And yeah, we need to continue with this logic down here. Okay, so let's have a look at what we are actually doing here. So we are from rows 2 and 5 removing everything except for columns 2 and 6. So that means that rows form an X-wing over the columns 2 and 6. Yes. Then we add a thing to columns 0, which is correct because this was shared. Yeah, okay. And then we expect these. Yeah, we expect the fin to stay there, but these two things to be removed. Yes. That should be correct. Okay, let's just... I need to visualize this because just staring at the numbers doesn't really work for me. So, okay. So I said that from... Yeah, okay, so we actually... Let's just... Come on. Right. So again, from rows 2 and 5, so it's these, we are removing those. Okay. Except for column 2 and 6, which is this one. Okay. So this and column and 5 is this one. Right. Okay, so this is after this loop. We have removed from columns 2 and 5, except for 2 and 6. Right. Perfect. And these are zero based, so yeah, that's it. So then we remove from row 5, no, re-add the thing here. Right, okay. So this is a thinned X-wing at this point, and what we expect to be removed are these two. So yes, so row 3 and 4, which are these two, should be removed. Correct. Okay. So now I kind of know what to expect. So what I want to do here is soft finned fish. I want to give it rows, so soft finned fish test dot rows, then the number, the size and the number, and the second function. Oh, so this is the function prune. Okay, so I can actually test what this gets called with. I don't actually need to implement this function yet. So basically over here I will have a lambda that is expecting unsigned number, unsigned block ID, unsigned position, and then a bit set of columns, I guess. Okay. And I just can write the requires over here. So I expect that the number will be 1, because that's what I'm calling it with. I expect that the block ID will be the this is the column, so this should be 2. Is that, no, sorry, it should be actually 0, because we added this one, and that's the 0th column. Am I doing it in the opposite way? Okay, let's quickly check what. So again, block ID is no, so this is actually the row in this case, and then I not yes, the I is the column. Okay. Oof, super hard to wrap this around my head. Okay, so this is actually the row. The rows should be 5. Or I guess 6, because this is actually the ordinal numbers. I need to keep track of that. That's an important distinction. And sure, let's just call it call. So let's just make it explicit. So this will be the row, the call row. So column should be 1, because again, ordinal numbers. And then the bit set. Okay, so I why am I writing request instead of require? I request that these two numbers are the same. Uh, so require that columns, the number of set bits should be free. So count set should be free. Was it count set? I used that somewhere else in this crazy big test. Count, yeah, count set. Okay. Come on. Okay. Over here, right. So count set should be free, and the bits that should be actually set is bit set. So I should have a 1 there in there because that's the same as the column of the fin. I should have the columns 2 and 6. Yes, so this should be 3 and 7. Okay. So let's just comment out this entire thing until the end of the file. Well, okay, that will be not that easy, but let's just do it in 2 steps then. Or 3 steps. Okay. Right. So I guess this should pass. I don't really expect it to, but let's see. Yes, I have typos, so unsigned doesn't like this. Why doesn't it like this? Okay, let's see. No match for operator. Where's it coming from? Line 240. Oh, yeah, this should go away. Okay. It was a leftover from the previous test. Wow, it's actually working? What the heck? Okay, I guess the thing I'm not actually checking if this gets called at all. I can check that. Well, okay, let's. Yeah, so I guess this was basically why this was here. So let's just quickly reintroduce it. Test data I times 9 plus j is the same as times 9 plus j. Right, so this should still work. Okay. With message 32. Okay. So that's a row for column 3. What? Oh, so that's this one. Yeah, so I don't think it actually called this function at all. Oh, that's annoying. Count equals 1. So basically means we never reach this point, which is a bit suspicious. Okay, let's just quickly drop into debug. That's an old one. I don't care about that anymore. And I don't care about this. I don't care about this. Okay. So let's see if we immediately drop out over here. Right. Actually, we basically know what this iter should be, right? It should be the iter should be 3 and 6 because those are the rows. Right, so iter should be how much? 3 and 6. Okay. Is this shift's not doing anything? Ah, okay, weird. So I mean, okay, so 32 and oops. Oh, what the heck am I pressing? 32 and 4, so 36. If I'm not screwing up completely. Yes, 36. So I'm looking for data of 36. Can I do conditional stuff over here? I guess over here. Yes, so iter dot data equals 36. Did it do it? I think it did. Okay. Okay, yes, so now we have 36, so now we should be in the correct thing. So after this loop, okay, so what do we have? Valid is true. Set, okay. Can I do, how do I do watches? And sorry for the debugging stuff being so small. I haven't figured out how to actually increase the font for these things. Okay, so the count set is 3, which is 1 higher than the size. So this should, yeah, so we are now here. Okay. So, okay, this is weird. Like, how did it not? Ah, of course, because I'm not actually removing anything from the puzzle. Okay. Right. So everything is actually working. I just am being stupid as usual. Okay. If I go back to the test, yeah. So this thing in here should be removing the, modifying the, you know, the puzzle, but it's obviously not because it's just checking stuff. So then obviously this will not happen, right? I mean, I can kind of, well, how do I do this? I can capture test over here and then just do basically hard code it. So test test the data this minus equals Okay, this basically. Because I know that if these things are correct, I know that basically the rest will be correct. So I can just hard code these two things, and this will basically tell me that this function actually got called. It's not perfect, but yes, okay, so now it's actually passing. Okay, cool. It was literally just that this didn't modify anything. In practice, this will be actually calling to something else to actually remove these numbers, but yeah. Okay. So, okay, that was just one of the tests. Now I want to reintroduce the other tests. But yes, just a short break again, I think. It has been, again, almost an hour. So, or I hope it has been. If I'm doing breaks at wrong times, then I'm sorry, but I'm losing track of time completely. Which I guess is good, but yeah, I just need to refresh my water and stuff. See you in 5 minutes then. Okay, and I'm back. So, I think we have 2 more tests to write. It was that one and then this one down here. But yeah, actually, one thing I want to kind of figure out is what the code actually would look like for doing basically these 2 lines, but actually as code, not just hard coding it in. So one thing is, this is actually 3 minus 1. Which is basically this. Okay. Yeah, it's not easy to... I really need to have like a reverse mapping of the 3x3 squares. Without that, it is kind of hard to figure out what this code would actually look like. Because yeah, basically want to figure out, okay, like which 3x3 square this belongs to. And then just based on that, remove this stuff. Yeah. Okay, so I mean, for now I can just leave this a little bit hard-coded. But I mean, this is still testing all the correct stuff, because, you know, if it finds the correct thing, if it returns the correct columns and everything, then it's straight up working. It's just that I'm not actually removing the numbers from the puzzle. But that's fine. Okay, so let's do the second test now. And I think I can draw it out to kind of visualize what the heck is happening, because otherwise this is really hard to understand. Okay, this goes there. So what are we doing? We are removing numbers. Okay, so this is testing the other direction, so this is testing columns. So from columns 2 and 5, or 3 and 6 if you count ordinal, we remove all the numbers except for rows 2 and 6. Okay, yes. And yeah, this is, yeah, it's literally the same thing, just like the other direction. Okay, so let's modify it very quickly. I will be inserting this dot data everywhere. Okay, this goes away. Oops. Right, and now I just need to change the indices. So times 9 plus 2, times 9 plus 5, times 9 plus 2, times 9 plus 5, and the same over here, times 9 plus 5, times 9 plus 5, 9 plus 3, times 9 plus 4, times 9 plus j, and over here times 9 plus j. Okay. So now, so this I want to search in the opposite direction, so this will be test. Yeah, so I switched to Visual Studio Code for a bit, because this is actually me working on my remote machine that has, because I installed a new Linux server physical machine that has bleeding edge OpenSUSE on it, the Tumbleweed, that has GCC 10.2.1, and I actually want to have a better setup, but I was struggling a bit with like remote desktop and stuff like that. I actually have it physically wired in into my monitor, but that's extremely inconvenient because I need to like on the monitor switch between the, you know, my main and my Linux server. So I wanted something like remote desktop, and the only thing I could get working was just remote development through SSH using Visual Studio Code. It works, but it's extremely frustrating because, especially for the code completion, like it works mostly, but sometimes it doesn't, and because it's like so inconsistent, it just keeps annoying me to no end. But yeah, I mean, I'm actually pretty impressed with it. Like it's a, for what it is, like it's just like a editor with bunch of plugins essentially. It's quite good, but it is annoying. I definitely intend to switch back to C-Line because that's just like, I mean, this is for free. C-Line is a commercial IDE, so it's kind of expected to be better and, you know, give you some extra benefits for the money you are paying for it. But yeah, like it works. I mean, what can I say? Okay, so this now will be column and row, and this will be rows, right? And I will need this kind of check over here. So okay, so what do I expect to happen? So number should be still 1 because that's what I'm calling it. The fin is this one, so the row of the fin should be 1 and the column of the fin should be 6. Count sets should be 3, and then the right, so it should be rows, and then the bits in the rows should be 3, 7, and 1. Yeah, okay, so it's basically the same thing as before, it's just rotated around. And the thing that should happen is basically this, yes. Okay, let's see if this works. It does. Okay. So yes, I'm starting to be confident about that this refactored piece of code actually works. But okay, let's try this last one. I remember this one was actually a bug that I ran into, and I introduced the test case just to make sure that the bug doesn't reappear. So this will be the last test case for this particular piece of code. Let's just get it out of here. Okay. Okay. Okay, these mini tests. And okay, bunch of these. I should have done just like a find replace instead of doing this manually. Oh well. Okay, but for the second part I can definitely do... Oops, that was too much. Alright, so replace the two brackets with times 9 plus. Okay. Replace all. Yes. That should be fine. Okay. So now I just need to change this call again. So this is actually looking for a big one. And shoot, I don't remember if this one is looking across. No. Across rows or columns. Because this was like removing all of the 8s out of the puzzle. Okay, let's just try to remember where was the finned fish over here. So it's a finned fish of size 4. So this. I don't actually see it. What the heck? It was. Is it? Was the bug that it actually isn't in the puzzle? Yeah, this actually looks like we are setting up the things the same way. Yeah, I think, yeah, this was the negative test, that it doesn't actually screw up the puzzle, because this doesn't have a finned fish in it. I mean, I can test that, yes. Yeah, okay, so I guess what I can do is test.rows, and then basically just have a function over here that just always like has a require that always fails. So if it gets called at all, this will just bail out, and I guess I can do it in both directions. So for both for rows and columns, I don't particularly need the expect at all, because yeah, man, it has been a while since I did this. I keep forgetting stuff, it's horrible. Right, so what were the parameters of this function again? Right, this thing. And I mean, I really don't care what the actual names of these are, because I will not be using it. What I care about though is straight up require false. I guess that should be fine. So it does get called. Okay. What the heck is the difference between these two things? Yeah, I think this is like the only way I can figure it out. Okay. Wait, what? Bad copy paste, what the heck? I mean, so far it's lining up. I mean, it's always possible that I actually have the same bug I had before in the code. Like, it wouldn't actually surprise me too much if that happened. Because I tend to be the person that just keeps repeating the same mistake over and over. Okay, so I think it lines up perfectly, so it really should be that it doesn't find anything, I think. I think that's the idea. Right, so because this is happening then, so what I actually want to do is reintroduce the parameters. I try to figure out what the heck is actually getting called with what. So info number, column, row. Okay, and let's just put some spaces in there. Row, and I guess rows. Oh, I do have the debug string on it, don't I? So let's just do that. Okay. And I guess the same thing over here, with just this should be columns. Row. Okay, and same idea over here. Let's see what's actually happening. Rows, what was not yes. So okay. Mistakes. Okay, so okay. So it's 844. So it's saying that the fin is at position 44. So 1, 2, 3, 4. 1, 2, 3, 4. So this would be the fin. So wait, actually, the problem is I don't know if this is the rows or columns that are actually failing. So let's just make it explicit. So this is rows. And this one is columns. Because otherwise I can be staring at it for forever and not figuring out what the heck is happening. Okay, so it's rows. So then so then this should tell me the columns across which it thinks that there is the fish. So 2, 4, 2, 4, 6, 8, 9. I mean, that's 2, 4, 6, 8, 9. Yeah, there's something broken here. Because I mean, this is not a fin. I mean, yes, so this is 5 elements in this array. But the problem is the number like when it counts the number of instances of the 8 for the column 4, it should come up with a 2. This is very peculiar. Or is it looking at like a different set of rows than I think? Well, I mean, obviously it has to be looking at this row, right? Like, so row 3 has to be in there. Since it's saying 9, then also row 4 or row 2 has to be there. One of those at least. But then, like, where's the 4th row? Oh wait, is it this, 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 and this? Is that actually a valid? So okay, let's look at it. So row 2, row 4, row 5, and row 6. That does actually form a finned fish, and this is indeed the fin. Then why do I have this test that says that this should not be removed? I mean, this should basically eliminate this 8. No? Oh my god, this is so complicated. Okay, I had a solver somewhere that actually was capable of doing this stuff. No, it wasn't a Sudoku. But was it a Sudoku? Damn it, one of these solvers was actually... Yeah, it wasn't the Sudoku. There was an online solver. Oh jeez, do I have it somewhere? Bookmarks. damn it. I don't think I saved this solver. No. Oh shoot, where was it? It was on the website that had like explanation of the XYW wing solver. Was it this one? No. Ah, damn it, why don't I bookmark things? I'm such a moron sometimes. Yeah, it's none of these, because this one is mine. This is the cracking the cryptic, Sudoku. Oh, why? Okay, let me just try XYW. No, W wing. Oh, was it this one? SudokuWiki.org. No. Oh, yes. Yes, this is the one. Oh, perfect. Okay. Oh my god. Geez. Right. Let's try to replicate this thing over here, and let's see. Let's just validate that this actually should be a finned fish. Okay, so this should be a 9. This should be a 3. This should be a 4, 7. Again 4, 7. And 8, 5, 6, 2, 1, 6, 2, 5, 3, 1, 9, 7 over here, and 4, 8 over here. Then an 8 over here, 1 over here, 1, 4, 7, 4, 6, 7, 4, 6, 2, oops, 3, 9 over here, the same over here. Then a 5. Okay. 5, 6, 8. A 2. 6, 8, 9. 7. 4. 1. 3. 8, 9, 3, 6. Okay. Almost in the middle. 4, 6, 8. 1, 4, 9. 2, 5, 6, 8. And yeah, basically then I really want to turn off everything except for what was it actually? Yeah, fint x, not fint. It's only Fint X-Wing, I don't see a Fint bigger thing. Yeah, okay, we'll see. We'll see when we get there. 5, where was I? 5's under 7, which is here. Okay, so 6, 8, I have that. 4, 9, 7, 4, 6, 8. 7, 4, 6, 8. 4, 9, 1. 6, 9, 3, 4, 5, 4, 5, 8, 9, 2 over here. Okay, 1, 2, 4, 5, 7, 5, 7. Okay, 4, 8, 4, 6, 9, 5, 3, 4, 6, 9. Okay, let's finish this up. Oops. 5, 1, 6, 9, 3, 4, and a 7. Right. Okay. So if I now do take step, so the 8 that we care about was this one down here, so it is this one over here. So if I do take step, wait a second, there were some hidden singles in there. How the heck did I even end up in this situation? This is so weird. No, so this actually is supposed to be the 8. So I definitely don't want to remove it, because it's actually part of the solution. What? No, there's an error on the port? Okay, back, reload. Did I screw it up somewhere? No, everything is wrong. Damn it. Okay. What's the time? This is nasty because considering that when I copy this, and I'm hoping I didn't make a mistake, the online solver basically screwed up. I have a suspicion that this is already broken puzzle. Which definitely could be the case. So maybe this test case doesn't matter. But I think I will try to figure that out offline, because I think how I will do this is basically I will try to copy this again into my solver and into the online solver and try to see what they do with it again. And this time actually save the puzzle, not be a moron as usual and not save the puzzle. Right. It's very strange because I kind of think that technically the solver is correct and this is a finned fish, but it's a really strange one. And yes, like if this is already broken puzzle, then it doesn't matter. But yeah, okay. I think I will stop for now today. My voice is actually dying pretty hard, so that's one of the good reasons. And yeah, I want to test this offline and figure out if it's actually a problem on my side or if it's just something weird happening somewhere. Because again, I'm really not sure how I ended up with this test case. It's a bit peculiar. I mean, I guess I can actually replicate this test case by just doing the 8s, right? Basically doing this. I mean, that will still take a while, so yeah, not the most amazing thing to do. Okay, anyway, I think that's it for today. Thanks a lot for watching. Like, I'm actually super happy with the progress that I made today. I will still try to basically, you know, figure out what the heck is happening with this particular thing. But I mean, we kind of went through the basic solving techniques. There's still a couple of things missing, but basically next week I should be able to just put it together and finally run some load tests and figure out like what's the difference in performance. Because I do actually expect the performance to be different significantly. We should be doing way less memory allocations, so that should already improve things massively. And the fact that basically everything now is just a loop going over the next instead of just this, you know, callback thing where, yeah, it was a reasonable idea, but it didn't really work out. So this should be much faster than the current solver. But yeah, like next week I'll be putting this together. So hopefully see you in the next stream. So the same time as usual, next weekend, 2:30 p.m. Central European time. I think that's like what? That's pretty early in America. So yeah, sometime in the morning in America if you are watching from there. And yeah, see you next time.